Interesting question to lead off with. Should children lift weights? And because this is also an interesting and often controversial topic, like there, especially if you come from an athletic family, there might be like, oh, I want my kids to lift weights, and but it's often controversial because the people are concerned, is this going to affect the child's growth and long-term health? So yeah, you might see once in a while these like these articles come out like, but we have this very young bodybuilder or power lifter, and this one over here, I think just last or 2 years ago, yeah, this like he's doing powerlifting. I think I saw an update like maybe in 2020, he was like squatting 165 pounds, so he's still at it. So this is an interesting thing, and we'll get to this hopefully by the end of this. But something to think about. We'll hopefully get to this by the end of this lecture. Okay, so now we have to talk about bone development, and this is also something linked to this question we're starting off the lecture with. So remember that key root words os refers to bones, and then osteogenesis. So whenever you see that root word genesis, think of something beginning, think of something being created, think about something being generated. So with osteogenesis, bone generate, you're generating bone. So osteogenesis is the physiological term for the generation of bone and formation. And ossification. So whenever you have something ification, that means it's becoming something. So what it is with ossification is becoming bone or forming bone from something. Now what do we have here? Well, we're having like, oh, this is the poor dinosaurs, and then the meteor hit, and then they became embedded in the bedrock, and then they became fossils. So just like how fossilization is the process of some organic material becoming a fossil, then bone formation, that ossification, well, one essential part of ossification is calcification. So that ification means becoming something, or like in a more serious thing, like if you're indemnified, is called indemnification when you get implicated in something. Hopefully none of you will be that, but yeah, or hospitalization or something like that. It's like all about becoming something. So when you have calcification, that's the tissue becoming calcified. And bone is one of the, remember that bone is a connective tissue, more specifically a support connective tissue, and that ground substance becomes calcified. And this is an interesting thing. So bone we expect to have calcium, but there are other tissues that can be calcified and is abnormal, but if we that's more something we reserve for the next semester. But yeah, we know bone definitely should be calcified. So ossification is tissues becoming bone. So there is bone doesn't just appear. It has to develop about out of something, right? So how do you develop bone from, like, remember we all start as a ball of cells, but how do we end up growing bones from that ball of cells? So one main process is called endochondral ossification. So, chondral, that sounds like chondro, which is that root word for cartilage, right? And endo, where have you heard that? Hey, that's a prefix that means within or inside something. So that's one of the main ways we generate bone in our body. And intramembranous ossification is the other main way that bones are made in our body. So we'll cover intramembranous or dermal ossification, that means the same thing. So this is, I'm just going to get this out of the way because it's a little, not, so only specific bones in your body undergo this process of intramembranous ossification. And remember, intra means within, so it's within some sort of membrane, and then it's becoming bones. That's the ossification part. So where does this occur? Well, this occurs even before you're born. So this is during the development of fetuses in the womb. And what it does is produce things called dermal bones. Now, don't get this confused with like your dermis, like your integument. So it's called dermal bones. They just call it that way. It's one of those things where you have the same word or something similar appearing in multiple different contexts. So don't worry about that. So what bones are formed during this mysterious process we call intramembranous ossification? Well, most of the flat bones in your skull and face. So you can feel the flat bones like on the top of your skull. So like your frontal bone, your parietal bones, and occipital bones. In your mandible, so your lower jawbone, and your clavicle. So if you don't know these bones, you'll become very familiar with them already. If you're not taking the lab, then this is probably the first time you're seeing it. So again, this unit from this point on until exam 2 is all about bones and muscles. And no cartilage required. So this is the main difference between that endochondral ossification and intramembranous ossification. So the biggest difference is that there's no cartilage in this process. All right, so basically what we have with intramembranous ossification, you have some sort of soft tissue. Now then you have some sort of solidification and causing it to be hardened. Now with bone, what happens is that we have mostly, remember that collagen, it's not just about calcium, but you also have collagen forming those solid protein fibers. Remember, bone is a connective tissue, so you need some sort of protein fibers or proteins, and you need the ground substance. But what you also have are inorganic components, so these aren't your biological macromolecules. So calcium, so even though there's a lot of calcium in bone, it's not like more than 50%. It's a big chunk of it, but this is the main inorganic component. And you also have things like phosphate, then carbonate, and then potassium, sodium, magnesium. So you need all these sort of minerals and also these ions to form the bone mineral that makes up the ground substance of bone. Okay, so intramembranous ossification, to summarize that previous video. So actually what we have are those mesenchymal cells. And remember, mesenchymal cells are a type of stem cells, and stem cells can become other types of cells. So the cool thing about these mesenchymal cells that form the dermal bones via intramembranous ossification is that they can start to develop into bone cells. And look, they differentiate into osteoblasts. And what do osteoblasts do? They secrete that osteoid that ends up becoming calcified. That eventually becomes bone tissue. So what we see is that these mesenchymal cells are becoming osteoblasts. They're secreting osteoid that becomes calcified. And as this text gets into things, so what we see is that the cool thing is that, okay, you also have blood vessels not only to keep these cells alive, but remember all those inorganic compounds, especially calcium, phosphate, and all those other minerals, you need a supply. How do you even get that to bone? Well, blood vessels are kind of like the highways of our body. They are able to transport things throughout our entire body. That's why we have blood vessels everywhere. So these blood vessels, things like calcium and phosphate, this dissolves easily in our blood. So our blood vessels are going to carry these raw materials and also other cells that help along with the building of new bone to the areas where bone is forming. So these blood vessels are carrying calcium, phosphate, and all the other good stuff. And this, remember, we have all these osteoblasts that are building new bone. And eventually, these are going to form, as these developing bone pockets of bone start to get fused together, they start to form a more cohesive, larger structure. And eventually, what happens is, this is why it kind of looks spongy as well, because it doesn't start off as just one huge solid chunk. You have all these little pockets, and they start forming bridges and connections. So this is why we see this kind of lacy, spongy kind of texture over here. So this is why the bones that are formed via this way are kind of have that look. So what we have here on the outside, they're pretty hard, but they also have this kind of spongy-like area. So where do you find these intramembranous ossification bones? I found this online. I like this because it really summarizes it really well. Notice that all of the bones that form via intramembranous ossification, well, they're the flat bones of the skull. If you don't know what flat bones are, we'll cover it pretty soon. And also your collarbones, or the medical term is the clavicles. So what do you notice about the intramembranous bones that are in this dark purple over here? Well, notice that they're toward the top. And what's encased within these bones over here? Hey, maybe that squishy, very important organ called our brain. Well, remember, go back a few slides. When do intramembranous bones form? They form during fetal development. So this is before birth. Now, what happens during birth? And unless it's a breech baby or cesarean, which part normally comes out first? This part over here. So what happens is that you have to push that baby through that woman's cervix and vagina. So it's a very big object coming through a small space. What happens to that object? It gets squished. So where do you want to protect? You want to protect that brain, right? So it makes sense that you want to have these strong structures formed before you even slide that baby out if you're doing a natural birth, because again, you want to protect the very vital organs, and there's a very important organ contained within this structure inside a baby. So this is the way I remember it. So intramembranous is not random, it's there for a purpose. But the thing is that, do you want all the bones formed? Well, if these bones aren't completely solidified and formed, that makes the whole birth process a lot easier. So if it's a natural birth, it's going to be a lot easier. You want to protect the vital organs, but you don't want everything being solid because that's going to be really tough to push through. Yeah, so the skull needs to ossify fast. I think that's a great summary of why this superior part, especially the skull, you have those bones forming before birth. Turns into pointy head. Yeah, so because again, if you look at the previous video, notice that it had a structure. It looked like a little X marks the spot. The thing is that if you've seen a newborn baby, they might have this little. Some people call it a soft spot. The proper term is a fontanelle, and it's actually the bones of the skull aren't fully fused at that point. So that happens as the baby develops. But again, you want a little flexibility. You want enough structure to protect the brain of the baby, but not so fully formed that it's hard to pass that baby through. Do not want to check. I know, it was like the good thing. Thank goodness for modern anesthesia.